two 2x2 centimeter plates that form a parallel plate capacitor are charged to 0.708 nanocoulombs. What are the electric field strength inside and the potential difference across the capacitor if the spacing between the plates is 1 millimeter and 2 millimeters? So, looking at the problem here, it looks like they give us an area and a charge. So let's write that down real quick. The area is 2x2 centimeters. 2 centimeters by 2 centimeters, which equals 4 centimeters squared, or if you convert that, 0.04 meters squared. And then the charge is 0.708 nanocoulombs, which, if you convert to coulombs, would just be 0.708 times 10 to the negative 9 coulombs, because it's nanocoulombs, so 10 to the negative 9. And let's see, they're asking for the electric field in the capacitor, so E of capacitor, we don't know, and they want to find the potential difference, so we don't know that either. A and B is either 1 millimeter, which is 10 to the negative 3 meters, or in part B, it's 2 millimeters, or 2 times 10 to the negative 3 meters. So for the electric field of a capacitor, we use this formula. E capacitor equals eta over epsilon naught. We know this is a constant, so we have to find this value, but remember, eta just means charge over area. So knowing that, we can just plug all these values in and get our electric field. So Q over A times, or charge over area times epsilon equals 0.708 times 10 to the negative 9 coulombs divided by the area, 0.04 meters squared, times the constant, 8.85 times 10 to the negative 12, and that should get you 200,000 newtons per coulomb. And it's the same electric field strength for both A and B because it's not dependent on distance looking at this formula here. But it is for potential difference because that formula is electric field times distance. And now that we know the electric field strength, we can just plug and chug for these. In part A, it would be 200,000 newtons per coulomb times 1 millimeter, 10 to the negative 3 meters. And then part B, it would just be 2 times 10 to the negative 3 meters. And for both of these, you get 200 volts and 400 volts, respectively. And these are your answers.